Hey everyone, Chris Fix here. Today we're diving deep into the world of car AC systems. It's summertime and the last thing you want is to be stuck in traffic with a busted AC. Not only is a working AC essential for comfort, but it's also crucial for safety, especially during scorching summer days. Think about it. A comfortable driving environment helps you stay focused on the road. When you're sweating bullets and struggling to breathe in a stifling hot car, your concentration and reaction time can be severely affected. This is a recipe for disaster. But it's not just about summer. Your car's AC system also plays a vital role in dehumidifying the air inside your car, preventing your windows from fogging up during colder months. This is essential for maintaining good visibility and ensuring safe driving conditions year-round. So whether it's the peak of summer or the dead of winter, having a properly functioning AC system is non-negotiable for a safe and comfortable driving experience. Now, let's pop the hood and take a look at the key components that make this cool comfort possible. All right, let's get under the hood and meet the team responsible for keeping you cool. The main components of your car's AC system, there are 5 major players here: the compressor, the condenser, the expansion valve, the evaporator, and the refrigerant. First up, we have the compressor, the powerhouse of the operation. This guy is responsible for compressing the refrigerant gas, which is essential for the cooling process. Think of it as the heart of your AC system, pumping refrigerant throughout the system. Next, we have the condenser, which looks like a small radiator located at the front of your car. Its job is to cool down the hot, high-pressure refrigerant gas coming from the compressor. Then there's the expansion valve, a small but mighty component that regulates the flow of refrigerant into the evaporator. This valve helps to lower the refrigerant's pressure and temperature, preparing it for the next stage of the cooling cycle. The evaporator is like the lungs of your AC system. It's responsible for absorbing the heat and humidity from the air inside your car, leaving you with cool, refreshing air to breathe. And last but not least, we have the refrigerant, the lifeblood of your AC system. This special fluid circulates through the system, absorbing heat from the inside of your car and releasing it to the outside environment. Now that you've met the team, let's take a closer look at each player and understand their individual roles in this cooling collaboration. Let's start with the heart of the operation, the compressor. This hard-working component is responsible for keeping the refrigerant flowing through the system and creating the pressure difference needed for the AC cycle to work. Imagine the compressor as a bicycle pump. Just like you pump air into a tire, the compressor pumps refrigerant gas through the AC system. But here's the catch: the compressor doesn't just move the refrigerant, it also compresses it, raising its temperature and pressure significantly. Why is this important? Well, compressing the refrigerant is crucial for the next stage of the cooling process. Think of it like this: you can't inflate a balloon without first creating pressure inside it. Similarly, the compressor creates the necessary pressure for the refrigerant to release heat and cool down. The compressor is typically driven by a belt connected to your engine's crankshaft. When your engine is running and you turn on your AC, the compressor kicks into action, pumping refrigerant and setting the entire cooling cycle in motion. So, the next time you feel that blast of cold air hitting your face, give a silent thank you to the compressor, the tireless worker that makes it all possible. Section 4, the condenser, cooling down the heat. Now that the compressor has done its job, let's move on to the next stage of the cooling process, the condenser. Remember that hot, high-pressure refrigerant gas we talked about? That's where the condenser comes in. Picture the condenser as a miniature radiator positioned at the front of your car, often right in front of the engine's radiator. It's made of thin metal tubes and fins designed to maximize heat transfer. As the hot refrigerant gas flows through the condenser's tubing, the condenser's design allows it to release the accumulated heat to the surrounding air. Remember those metal fins? They act like tiny radiators, increasing the condenser's surface area and allowing it to dissipate heat more effectively. Think of it like this: when you're overheated, you sweat to cool down. Similarly, the condenser helps the refrigerant sweat out the heat it absorbed from inside your car. By the time the refrigerant leaves the condenser, it's much cooler and has transitioned from a gas to a high-pressure liquid, ready for the next stage of its journey. Section 5, the expansion valve, a pressure regulator. We've compressed the refrigerant, heated it up, and then cooled it down. Now it's time to regulate the flow and prepare it for the final stage of cooling. This is where the expansion valve, a small but mighty component, takes center stage. Think of the expansion valve as a gatekeeper, carefully controlling the flow of refrigerant into the evaporator. It acts as a bottleneck, restricting the flow of high-pressure liquid refrigerant from the condenser and allowing it to enter the evaporator at a much lower pressure. This sudden drop in pressure causes the refrigerant to expand and evaporate, changing from a liquid to a gas. This evaporation process is crucial for cooling because it allows the refrigerant to absorb heat from its surroundings. The expansion valve is designed to maintain the optimal pressure difference between the high-pressure side, the condenser, and the low-pressure side, the evaporator, of the AC system. This precise regulation is essential for the efficient operation of the entire cooling cycle. Section 6. The evaporator, your car's personal chiller. We're in the final stage of the cooling cycle, and it's time to meet the evaporator, the star of the show, when it comes to actually cooling the air inside your car. Located inside your dashboard, the evaporator is another type of radiator, but instead of releasing heat, it absorbs it. As the low-pressure refrigerant flows through the evaporator's coils, it evaporates, changing from a liquid to a gas. Remember that when liquids evaporate, they absorb heat. That's precisely what happens here. The refrigerant, now in its gaseous state, absorbs heat from the air blowing over the evaporator's coils. Imagine the evaporator as a sponge, soaking up the heat and humidity from the air inside your car. The result, cool, dry air, is blown into your car's cabin, providing that refreshing relief from the summer heat. So, while the other components work behind the scenes, the evaporator is the one directly responsible for keeping you cool and comfortable on those scorching summer drives.